Good day, sir.
Hi, I'm Lawrence Camile.
Hi, I'm Ronald C. Valdez Jr.
So today we're going to
give some lecture about free fall motion. First is, we have 3 examples in what happens in real life situations about free fall motion. First is, when you drop a rock from a cliff,
what will happen?
obviously it falls downward. Second is, when a skydiver jumps from a plane,
What will happen?
answer is, he or she will fall to the ground. And last is, what happens to a skydiver's speed as he is falling down?
It will reach a terminal velocity due to air resistance.
We have 3 goals for today. First is to perform an experiment to analyze a free-falling object, and second,
To determine the value of G, also known as gravity.
and last is to enable you to solve problems dealing with free-falling objects.
So what is free fall motion? A free falling object is an object that is falling under the sole influence of gravity. Any object that is being acted upon only by the force of gravity is said to be in a state of free fall.
So, there are 3 properties of motion. First is the displacement, second is velocity, and last is acceleration. First is displacement. Displacement is the distance and direction traveled.
Alex hits a man run. What is his total displacement around the bases?
So the answer is 0. And next is the velocity. The formula in getting the velocity is equals to displacement over time. So I have one example. A home run takes about 3.5 seconds to clear Lawrence center wall 420 feet. What is the velocity of the ball?
So here is the solution. So first you're gonna substitute each numbers to the formula. So here divide to 3.5 seconds, then this will be the answer.
So for every second the ball travels 120 feet. Second is the acceleration.
Average acceleration. So the formula is change in velocity over change in time. So here it is.
Example of this is a car does 0 to 85 meter per second in 6.4 seconds. What the average acceleration for this interval of time?
So in this question we want to find its acceleration. So here is its formula.
First is, you need to substitute all the given numbers. So 85 meter per second minus 0 meter per second over 6.4 seconds minus 0.6 seconds. And the final answer is 13.28 meter per second squared.
So for every second, the velocity increased by 13.28 meter per second squared. So vector and scalar quantities.
A vector quantity has size and direction. Example, displacement, velocity, and acceleration.
A scalar quantity has only size and no direction. Example, distance and speed. Here is some formulas that you should take down notes.
That's all for free fall motion, and we're here. And let's move to the next topic, which is the
projectile motion. So projectile motion. What is projectile motion?
Projectile, any object which projected by some means and continues to move due to its own inertia or mass.
So projectiles move in two dimensions.
Since a projectile moves in two dimensions, it therefore has two components, just like a resultant vector.
So horizontal.
The two dimensions of projectile is horizontal and vertical. Horizontal velocity components.
Never change. Cover equal displacement in equal time periods. This means the initial horizontal velocity equals the final horizontal velocity.
In other words, the horizontal velocity is constant, but why?
But why? Gravity does not work horizontally to increase or decrease the velocity.
So next is vertical velocity component. Changes due to gravity does not cover equal displacements in equal time periods.
So both the magnitude and direction change. As the projectile moves up, the magnitude decreases and its direction is upward. As it moves down, the magnitude increases and direction is downward.
Horizontally launched projectiles. Projectiles which have no upward trajectory and no initial vertical velocity. So velocity of horizontal velocity is equals to 0 meter per second, and velocity of vertical is equals to v horizontal is constant.
Horizontal launch projectiles. To analyze a projectile in two dimensions, we need two equations. One for the x direction and one for the y direction. And for this, we use kinematics. Number 2. So here it is.
X is equals to velocity horizontal velocity time plus 1/2 acceleration times time squared. X is equals to horizontal velocity times time.
Remember, the velocity is constant horizontally, so that means the acceleration is 0.
Y is equals to 1/2 times gravity times time squared.
Remember that since the projectile is launched horizontally, the initial vertical velocity is equal to 0.
So we have one example about horizontally launched projectile. Example is
a plane traveling with a horizontal velocity of 100 meter per second is 500 meter above the ground. At some point, the pilot decides to drop some supplies to designate target below. How long is the drop in the air? B. How far away from point where it was launched will it land? So here is the given.
Horizontal velocity is equals to 100 meter per second, and the distance is equals to 500 meter, and the vertical velocity is equals to 0 meter per second, and the gravity is negative 9.8 meter per second squared.
So this is what we're going to find. So here is the formula for time. So for the time, this is the formula. So here it is. So this is the answer.
And in B, which is how far away from the point where it was launched it land. So in finding the answer of B, this is the solution. So x is equals to horizontal velocity times time. Substitute is equals to 100 times 10.1, and the answer is
Here it is. So here is another example. A place kicker kicks a football with a velocity of 20 meter per second and at an angle of 53 degrees. So here's the question: how far away does it land?
so this is the given. Horizontal velocity is equals to 12.04 meter per second, and vertical velocity is equals to 15.97 meter per second, and the distance is 0, and gravity is negative 9.8 meter per second squared.
So how far away does it land? So here is its solution.
So x is equals to horizontal velocity times time, and substitute 12.04 times 3.26, and the final answer is 39.24 meter.
So
That's all. Thank you.
Hope we help you in.
And we give some knowledge about free fall motion and projectile motion. Thank you.